righty, we are looking at question number 6 on the AB exam of the 2023 AP Calculus Administration. I have not read the questions yet. I am solving these in real time, so you can kind of see how I process a problem when I read it for the first time. That may lead to me having to stop and think for a minute on a few since I don't have prefabricated solutions. So let's go on and look at number 6. And, implicit differentiation. Oh, man. I haven't asked that in a long time. Well, I shouldn't say that. It's a nice question. It's a nice question. All right. So the curve is this, and I don't always rewrite the equations and stuff. It does help you just kind of process and look at what's going on. There's my curve. Show that dy dx equals this. This is a nice question. This is a proof. They gave you the answer. You just have to show how that happens. And so I'm going to differentiate that. For 6xy, that is a product, and I'm going to look at it as 6x. Actually, I'm going to leave the 6 alone. I'm going to leave the 6 out. The derivative of x is 1. Leave the y alone. Leave the x alone times the derivative of y is dy dx. The derivative of the right side would be 3y squared dy dx. And then we need to solve that for dy dx. So now I'm going to distribute that y. So 6y plus 6x dy dx, and you can use y prime. There's nothing wrong with using y prime instead of dy dx. The problem with y prime is it looks a heck of a lot like y to the first power, and it can lead to just careless mistakes. So I like to use dy dx. It's a little bit easier to identify. And because I have the solution, I want to have a y squared minus a 2x. Okay, I'm going to move this y term in, and you may have the ability to solve these or to finish these differential equations, to finish these implicit differentiation problems in one step. But because we are given the solution and we are proving that the solution is what it is, you don't want to skip steps. I'm going to go through little bitty baby steps here. So I'm going to move my 6x dy dx over. I will factor out. The dy dx is 3y squared minus 6x. And then I will divide, so dy dx would be 6y divided by 3y squared minus 6x, which normally I am perfectly content stopping there. But again, we're proving that the answer is 2y over y squared minus 2x. And so I'm going to go a little bit further. I'm going to factor the 3 out of the denominator. And again, I don't want to skip steps because this is a proof. You probably would be safe skipping a little bit, but I just feel more comfortable showing every nitpicky detail. Am I done? I am done with part A. So good old implicit differentiation problem. Give me some more room to work. Number B, find the coordinates of a point on the curve at which the tangent line is horizontal. So a tangent line is horizontal means the derivative would be 0. So for B, I need dy dx to equal 0, which is going to happen when the numerator, I will go ahead and write the whole thing, y squared minus 2x equals 0. That will happen when y is equal to 0. And then just something you want to be aware of, we want to make sure that while the numerator does need to be 0, we want to make sure that the denominator is not also 0. We do not want to have a 0 divided by 0 situation. So just kind of have that in the back of your mind as we work through this problem. We just found out that y is equal to 0 is the time when the derivative would equal 0. I'm reading the question again. With the tangent lines, explain why no points exist. So right now it does look like a point will exist, and that is when y is equal to 0. I do need to find the x because it did say find the coordinates. And to find the x, we will plug 0 in for y up here. And oh my goodness, how evil are these people? Sneaky, 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 sneaky. So now I need to find the x that corresponds with that y by plugging in 0 for y. So I'd have 6 times x times 0 is equal to 2 plus 0 cubed. And we get the lovely statement that 0 is equal to 2, which means no such point exists. I don't know if I've seen that before. Maybe I have. Maybe I'm just getting old and forgetting what I've seen in the past. Usually it works out quite nicely that you get like x equals 5, and you have the ordered pair 5, 0. It didn't happen this time. There's no solution to this. And so I'm going to say, therefore, no such point exists. I don't know. Now, this is a unique question, or should I say rare question. Therefore, no such point exists. I do not know exactly what they will look for in your justification for no such points existing. I feel like I have done a good job explaining that. I found my y. I showed that when I plug that y into the original equation, I get a no solution situation. And so I feel like that is sufficient. I'm very confident that would give me full points. So hopefully it does. And I'm going on to part C, which at a glance just a second ago, it looks like we're going to look for vertical tangents, and we are indeed. So a repeat of the last question, except I'm looking for places where the tangent would be vertical, and a tangent is vertical. So vertical tangent has an undefined slope. And so I'm thinking back to my derivative. By the way, you don't have to write that down. That's me kind of being a teacher and helping and explaining in more detail how I'm thinking. I would probably not have written that down if I were actually taking the AP exam, but an undefined slope is in, and this is my brain here. That's when you have like some non-zero number divided by zero. That would be an undefined slope. So I need to see, man, I've got hiccups here. I need to see what makes my denominator zero. And so I need y squared minus 2x to equal 0. And this is an interesting one. I can either solve for y or I can solve for x. Solving for y is going to be trickier because I'm looking at I need to focus on what I'm doing right now. I'm trying to think too far into the future. Solving for y is going to be trickier because if I move that 2x over and then I square root that, I will have a plus or minus square root of 2x. And I don't want to have that positive and negative option there. So I'm going to solve for x instead. X is going to equal y squared divided by 2. Okay, this is not going to be as bad as I was thinking. Okay, I'm double checking to make sure that is correct. Y squared divided by 2. Yes, that would be correct. Then to solve for the points, notice I don't have a numeric value for either one yet. I'm going to take that y squared over 2 and I'm going to plug it in for x here. So I'll have 6 times the quantity y squared over 2 times y is equal to 2 plus y cubed. And we're going to solve that. And so that will be 3y squared times y is 3y cubed equals 2 plus y cubed, subtract the y cubed, 2y cubed equals 2, and we get y is equal to 1. Now I need to find the x that goes with that. I can either plug 1 in for y up here and solve for x, or I could plug 1 right here because I know that x is going to equal 1 squared over 2. So x equals 1 squared over 2, which is 1/2. Therefore, there's a vertical tangent at the point 1/2 and 1. And boy, be very careful there. I almost said 1/2 because that I have them written in that order right here. So x is 1/2, y is equal to 1, and we are good. We're good on part C. And then finally, part D. We'll see how this one is. A particle is moving along the curve at the instant when the particle is at point 1/2 negative 2. So that's not the same point we had just a second ago. Its horizontal position is increasing at a rate of this. What is the value of dy dt? Okay, so this is a related rates problem. This is how they have typically asked related rates of lately. They just squeeze it into another part. And this one's really not a bad question. So we are looking at the point 1/2 and negative 2. So we know that x is 1/2. We know that y is negative 2. They tell you that the horizontal position, they just straight up said dx dt. Okay, so we don't even have to worry about interpreting the horizontal motion. So dx dt is 2/3 units per second. What is the value of dy dt? So this is, we're going to do implicit differentiation. I need to differentiate the original equation with respect to t. So I think I'm going to rewrite it here. 6xy, 6xy equals 2 plus y cubed. And then I want to differentiate this fella with respect to t, which we will again have that product rule on the right side. I'm going to ignore the 6. The derivative of x will be dx dt. Leave the y alone. plus x times the derivative of y. Remember, we are doing the derivative with respect to t, so everything gets that implicit treatment. 2 will zero out as we differentiate it. Y cubed becomes 3y squared dy dt. And now we substitute everything we know. So 6 times dx, which is 2/3, times y, which is -2, plus x, which is 1/2, times dy, which we don't know, equals 3y squared. So it'll be 3 times -2 squared dy dt. And we have to solve that for dy dt. And the arithmetic is, I think, harder than the calculus here. So that's 6 times -4/3 plus 1/2. And I'm going to change my dy dt to y prime now, since there's only the one variable remaining. That'll just be a little bit easier to write. Equals 3 times 4 is 12 y prime. This is going to get nicer as I distribute my 6. That 6 times -4/3 is -8. Plus 3y prime equals 12y prime. Subtract the 3y prime, and you get 9y prime. Divide by 9, and I end up with dy dt, which is my y prime, is -8/9. And what is the value of dy dt, the rate of change particles? So we don't need to worry about units. We don't have to interpret that. We are done with the free response questions on the AB exam. Hopefully you did quite well with those. I feel like they were fairly nice questions. They always throw in a few little wrinkles and some challenging ones, but on the whole, I feel like this was a pretty nice free response question section for the 2023 exam.